Hello to our YouTube audience. We'll be starting very shortly. Okay, we'll get underway. We haven't got our panels here yet, but they'll come on. It's going to be one of those shows. I bet it'll be a good one, so we'll get going.
The broadcast is now starting. All attendees are in listen-only mode.
Okay. Hello, everybody. Welcome to episode 8 of the Indo-Pacific series with My Security Media, My Security TV, and our partners, Aerospace and Defence Consultants Association of India. We look at aerospace, defence and security technology and market trends, opportunities with India, Australia and the ASEAN region. My name is Chris Cubbage. I'm the Executive Editor and Director for My Security Media here in Sydney, and my co-host Raman Sapori in Delhi. Raman, thank you very much for joining us.
Thank you, Chris.
Very good to see you. And this particular episode, we are still waiting on our two panelists from different parts of the world, but they'll come on. So as per normal, we'll go through the introductions to our episode. As anyone who's following us, we've got over 200 registrations for the series week to week. The main focus is aerospace and space, and I will cover off briefly, but happy World Space Week 2020, and that is what we're going to be looking at today in our aerospace and space domain. We also look at defence and national security, cybersecurity and critical technology, cities and infrastructure, and the protocols are these sessions are recorded. They're live on YouTube, and if you have any questions of the panel or of us, please fill out the chat line there as part of the GoToWebinar platform. As I mentioned, we're just waiting on our panelists now. I think Andy Koronios, the CEO and Managing Director of SmartSAT CRC, Cooperative Research Centre, he is based in Adelaide in Australia. He will be on about 4:15 or 4:15 the hour, if not a little bit earlier, and I'll just keep an eye on him as he comes through, and I'm just going to check as we speak because he's literally just coming on now. Good timing, Andy. I'll wait for you if you can hear us. No? I'll keep going, and then from here he comes, keeping us in suspense. Andy, can you hear us? Just waiting on your camera.
There's always a time lag between the space and the Earth station.
Correct. Just waiting on Andy now. I can see his camera's there. He'll be on in a second. And likewise, we're also waiting on Andrew Bowyer, Chief Executive Officer for KLEOS Space in Luxembourg. It's quite early in Luxembourg. I believe it'll be about 7 a.m. So we'll give Andrew some time. And we've basically got the two Andys from different parts of the world. So, Andy Koronios, I can see that you're on and off. Let me know if you're having any problems. That's okay. Look, we'll keep going and we'll walk through the episode. So, the beauty of this particular episode today, and we do appreciate Andy and Andrew joining us, and I'm just looking at Andy coming on. You should be able to hear us, Andy. No? I'll keep going. And this follows on episode 4, where we covered on space, where we had Subha Pavaluri from India, Malcolm Davis from ASPI in Canberra, Yoichi Kamiyama in Tokyo from the Japan Institute for Space and Security, and Glenn Tyndall, the CEO for Communication Systems at KLEOS. So that episode is available, and this is our second episode covering off on the space domain. Last week we looked at robotics and autonomous systems, and very much connected to the space domain as well. That was a very good session. Monica Minolta in Australia, and then also Andrew Yu from SD Engineering Electronics in Singapore. And as I mentioned, this is World Space Week. So it's the United Nations General Assembly declared Space Week from back in 1999. The Space Week commemorates two dates. One is the launch of Sputnik 1 in 1957, and then the signing of the Treaty on Principles Governing the Activities of States in the Exploration and Peaceful Uses of Outer Space, including the Moon and other celestial bodies, back in 1967. And I would suggest that the world is in some sort of space race at the moment, so it'd be interesting to see how that treaty continues to formulate. We cover space on our DRASTIC channel, Drones and Robotics. DRASTIC stands for Drones, Robotics, Automated Systems, Technology, Intelligence and Communications. There is a range of space-related content on there, and KLEOS obviously features quite prominently as well, just recently signing a distributor agreement here in Australia. Just some news from the week. Literally today, the quadrilateral dialogue is on with India, America, Japan and Australia. So Pompey is heading into Tokyo. It'll be interesting to see what sort of public statements are made from the Quad meeting. And some news from Oman. US has approved 90 million Lockheed Martin's aircraft following follow-up support to India. So obviously that is strengthening the ties with Lockheed Martin in India. And thanks for this one, Raman. You've now got the world's longest highway tunnel, 46 kilometres. Is this near you at all? You're in Delhi?
This is from a hill station called Manali to the region in Ladakh. It's a very strategically important tunnel in India and the world's longest highway tunnel. It's an engineering marvel and an engineer's delight. And it was, dedicated to the nation just last week in the memory of our late Prime Minister Atal Bihari Vajpayee by Prime Minister Modi. You are welcome to visit India and never miss to drive through this tunnel. It's going to be a nice experience. And now this particular road would be all-weather road, 24/7, 365. Earlier, before this tunnel was there, we had to close the highway for about 4 to 6 months due to heavy snow on the hills. It's an important strategic thing, and then India is going to benefit. A lot of economic activity will take place because of this. Hilly people are very happy because now they can get the food security, the industrial security. Also, a lot of investments is coming in this region because this is very rich in solar, energy. This area itself. Thanks to you, Chris.
Thank you very much. Not bad. Cutting 4 to 5 hours travel time, which is pretty significant. So well done, and be interested to see how that goes. 46 kilometres. The other one, India with Tesla CEO suggests India entry into 2021 as early as next year for the electric car market. And that's you there at Lowy Automobiles there, is that correct? With an electric tuk-tuk.
Lowy Automobile is a company 3 hours drive from Delhi. I visited them and they are now producing 3-wheelers, 2-wheelers and motorcycles fully electric. And all the parts are in.
How's the charging infrastructure around India?
Absolutely. Now, this is going to be part of the smart city infrastructure. We're going to build up this. Almost 40% cost of the whole vehicle is the battery. So is there anyone from Australia, anywhere else, who wants to be part of the supply chain to this particular engineering marvel? Most welcome. There are different versions of that. Next week, we'll put the brochure of this particular thing. So we are also having a practice in our association to convert auto to aerospace industry. Anyone who's having business downturn, we can shift them from auto to aerospace. This is going to be the next turning point in India and all over the world. Everyone is rushing towards the first electric vehicle. In fact, my own next vehicle would be electric.
Of course, I'm waiting on mine. And just briefly, I've just made a note. There is a Queensland company that builds the charging stations, and we'll reach out to them and see what they're doing in India. I know that they have been in the export market as well. So that's pretty much the news of the day. I didn't cover too much on the news. Just some key events that we're running. That we're supporting. One is with our partner, the ISAC Japan, International Security Industry Council of Japan, and James there. This is on tomorrow, and Challenge of Change, Japan's defence policy in the new Suga administration. So one worth having a look at. That's 9 o'clock Tokyo local time. The other one is the Asean Summit, the IBM Security Virtual Summit for ASEAN region. That is available if you go to our ASEAN channel. You will be able to find that link through. So that is on-demand content. And we recently interviewed in Singapore the Global Resilience Federation CEO, Bill Nelson, and it's a very, very interesting interview there with Jane Lowe, our Singapore correspondent, looking at the cyber threat intelligence landscape, particularly between the financial markets in the US and globally, and how that trend is continuing to grow. So again, the GRF, Global Resilience Federation, is now basing itself in Singapore as well. As we have been saying week to week, the Top Women in Security Malaysia nominations are closing, just a couple of weeks to go. And we are getting nominations coming in quite strongly, so that's one to support. And 3D Printing World, just a couple of months away as well in India, the 5th and 6th of December. Some other events, if you want to find out what's going on, both locally and internationally in the industry, welcome to go to the marketplace. So there's a range of new events. GovWare is also on this week in Singapore, and then there's a number of other events next week in Australia and the region. And some interesting reports coming up. A good Closing Australia's Skill Gap from Swinburne University was released the other day, and the Q2 Nexus Guard threat report also came out today. So that's much from the marketplace. Just 1 second while we onboard our panel, and just one sec. Andy is with us. We're just going to onboard you, Andy. Just 1 second. So Andy, are you? I can see you're on mute, and I can see your camera. You should be getting a camera request. Just bear with us, ladies and gentlemen, while we bring on our panelists. And Andy, just 1 second. Andy, can you hear us? We should be able to hear you. How's that, Andy? Okay, for some reason, we're not getting him. Something's happening here.
Hello, can you hear me?
I can, yes. Well done.
Oh,
We've
wow.
got sound.
Okay.
We just need...
Which planet is it calling from?
The planet Adelaide, but
Okay,
I think it's, yeah, I'm not sure if it's a Mac or not. I haven't used GoTo before.
are you on a Mac,
but
are you?
I'm on a Mac, yes.
Okay, sometimes we have had issues on the Mac. Just
Which
out of
browser
interest,
are you?
yeah, if it's a Mac, we might get some issues on the video. Do you happen to have a second computer?
Yes, I have another Mac.
Look, I
So,
do have your slides, so we
At
could
my
potentially...
slides, I think the quickest thing to do is for you to drive the slides and
Right.
for me to
Yes.
speak. It's not very consequential for people to see my face.
Absolutely. Thank you so much. Look, just bear with me while I bring up that presentation. Just 1 second.
Sure.
So, Andy, thank you so much for your time. Very much welcome you. You're the CEO and Managing Director for the SmartSAT Cooperative Research Centre in Adelaide. And happy Space Week to you. Thank you so much for your time.
It is my pleasure, and happy Space Week to everyone. I think this is the second day of it, and this is my second presentation. So I'm delighted to be with you and your listeners, and to share with you some of the activities of the SmartSAT CRC.
No
If we
problems.
can go
Look,
to
and
the
you
next
just,
slide.
yeah, you just guide me through the slide deck.
Okay. Thank you very much, everyone. The SmartSAT Cooperative Research Centre is an Australian government program that has been in existence for a very long time. That is, the program has been in existence for a very long time, and we spend CRCs, Cooperative Research Centres, are meant to bring industry and academia together to solve some very large challenges of the country, or to seize some very large opportunities. And it is something that allows us to actually bring industry and the research environment, and specifically universities, much closer together in collaborative and applied R&D. Unfortunately for Australia, we don't do very well in terms of university industry collaboration. We are indeed among the lowest of all the OECD countries in that area, yet we are pretty good in R&D. We are in the top 10 in terms of research outputs, but not in terms of monetizing those, adding value from those research outputs, and particularly through partnerships with the Australian industry in general. So we felt a consortium of universities and industry felt that given the significant opportunity, the significant global opportunity in space, and particularly new space, the Space 2.0, we wanted to actually bring the industry, small as it is, but growing, together with our universities, which have quite good capabilities in a number of areas in space, to bring them together so that we can indeed provide some value, and that will allow us to really become a global player in space. As you know, we were very lucky 2 years ago or less than 2 years ago in Australia to have a new space agency. And there is so much excitement now in the space industry for us to actually build a new high-tech country in this particular area. If we can go to the next slide, please. So who are we? The SmartSAT CRC is a consortium of more than 100 organizations, Australian and global organizations. We have 31 industry partners. Some of them are global players like Airbus and MDA and British Aerospace and others, Northrop Grumman from the US and others. Some of them are Australian SMEs. And of course, we have a very large number at the moment, around 66, I think it is, space startups that have joined the journey of actually building an industry through R&D. We were very lucky to raise $245 million in R&D over 7 years. And with that, we hope to focus on a number of areas in the space value chain where we feel Australia has significant capability, and we want to augment and add to that capability through building our capability in Australia, but more importantly also through collaboration with many other international players like ESA and DLR and NASA and colleagues from universities from around the world, from India, from Europe, from North America, and so on. If we can go to the next slide, please. We have decided to focus, after having a very large number of workshops here in Australia with our industry partners and universities, we have decided to focus in 3 large areas. One is advanced communications, connectivity, and particularly IoT technologies, particularly as they apply to space. And the second one is advanced satellite systems that actually use AI tools on the platform itself, on the satellite itself. As you know, these days, because the miniaturization of computing has continued to follow Moore's law, we are able now to pack very high computational powers on very tiny satellites. We're talking about 6U satellites could actually carry payloads with 1 teraflop of computing power. That is significant. That is enough to be able to actually not only just have advanced onboard processing, but actually to put machine learning algorithms and other AI tools on the platform itself, so that the onboard, the satellites can become autonomous, they can become cooperative, they can move in swarms, so you have swarm intelligence, and also become self-healing. Now, they are properties and capabilities that even the large bus-sized satellites don't have or haven't until recently, and yet the smaller class of satellites is now able to take advantage of those, as mobile phones are able to be pretty much supercomputers in your palm compared to, say, 10, 20, 30 years ago. But it's not only the satellite itself to be intelligent, we also want to have intelligent payloads so that the processing of whatever they do, whether it is a communications function, whether it is an Earth observation or remote sensing function, we want them to process the data as they capture it and in an intelligent way to send down information, to send down alerts, to send out actions and so on. That is what we want to achieve in Program 2, the Advanced Satellite Systems, Sensors and Intelligence. And of course, the third program is all about next generation Earth observation, about how can we do the next generation of remote sensing, both by building better remote sensors, whether they're optical, whether they are active remote sensing with radar, LiDAR, and so on, but also how can we do better analytics of those, and how can we provide information to the end users, information products that the end users can use. End users like farmers in agriculture, miners in mines, defense personnel. They're not interested in data. They're interested in actions. They're interested in advice on what to do next. And in many cases, they're interested in actually having the system being automated so they don't even have to be part of the loop. They are the leapfrogging technologies that we are aspiring to do in this SmartSAT CRC. And of course, as with all activity in a digital world, we want to make sure that everything is resilient and secure so that we are able to conduct communications with assured security and assured resilience. If we can go to the next slide, please.
And I'll come back on some of those, Andy, in terms of AI and cybersecurity as well, but keep
Sure.
going.
So our kind of vision, if you like, together with our partners, not only within the CRC, but all of the collaborations that we are crafting now and the work that we do with other large universities, research organizations, both here and overseas, and of course under the direction and coordination of our space agency, the Australian Space Agency. We want to make a contribution to actually building the nation's space infrastructure. We have some satellites, of course, some communication satellites, particularly Optus and NBN have satellites for communications and broadband. But we don't have a lot of Earth observation capability. We want to actually improve on that. We want to really provide that for all sorts of different actions and uses and applications. If you can go to the next slide, I'll give you just a taste of some of the things that we really want to do. We are taking a missions-based approach, and we are taking an approach together with many others, of course, here in Australia at the moment, in trying to contribute towards solutions of grand challenges for the country. And of course, water is a grand challenge for Australia because we are the driest continent on Earth. We want to be able to actually manage our water, both the quantity of water that goes in and the quantity of water that leaves our waterways and our water bodies in Australia, particularly fresh water, but also how can we find cost-effective and efficient ways to manage the quality of the water so that the fish don't die, so that we can have cleaner water for agriculture and for many, many other applications. We are partnering with the CSIRO, a very large research organization here in Australia, and we have the ACOWATS water management program. That is a program of projects, a collection of projects that will provide real-time monitoring of our waterways. But also, as you know, year after year, if one part of Australia is not burning down to a cinder, the other part is actually drowning with floods. Every year we have that problem. We will not just use technology to solve this problem. You need a lot of effort, a lot of contributions, but technology can play an important role in actually making our country more disaster resilient. And that is the type of mission that we will play and the role that we will play, particularly around bushfires and floods in Australia through our disaster resilience technologies program. And finally, of course, as all your listeners would know, Australia is a very large continent, a very large country, a very large continent. And indeed, if you cover the landmass of Australia, its territories, as well as the 200-mile or kilometer economic exclusion zone that Australia has with its seas and oceans, you are then accounting for 1/10 of the planet. So in terms of protecting our borders, in terms of protecting our sea resources, and very importantly, search and rescue responsibilities that we have, we want to be able to do that. And we will be working together with defense. Defense is a major stakeholder and contributor to the SmartSAT CRC, and therefore they also have some objectives that we will help them meet those objectives. If we can go to the next slide, please. So the ArcoWatch, as I've mentioned, is very much a coordinated program providing 24/7, 365 days a year water monitoring through constellations of satellites, but also integrating the data with in situ data, in situ sensors. We have on many of our waterways sensors, water quality and quantity sensor measuring devices, but obviously that's not cost effective for the whole country. It's a very large country, and therefore it is just not cost effective, and equally it does require maintenance because these things break down, sometimes they are stolen, and all sorts of hazards that they may have. But having those sensors and collecting the data via satellite rather than the terrestrial communication systems allows us to then have a validation of the water monitoring exercise throughout Australia. That is a program that we have now developed a number of projects, 3 projects in particular, but there will be a lot more coming in the next 2 or 3 years, and we will be building and launching a mission of satellites progressively in the next 6 to 7 years. We can go to the next slide. We also want to ensure that we connect Australia, provide ubiquitous, reliable and secure communication and connectivity for Australia throughout. So we will be using some very advanced MIMO and cooperative communications technologies that are used in terrestrial systems. We want to use them in space. We already began with some projects around optical communications, terahertz communications for intersatellite communications technologies, and we want to be able to, over time, be able to provide communications throughout the country as a hybrid and fully integrated system, not just terrestrial communication systems, not just satellite communication systems, but fully integrated and fully software defined, so that you are able to actually provide that connectivity, and particularly provide connectivity through disasters as well. Because as we've seen time and again, when you have a disaster, whether it's a flood or whether it's a bushfire, as we saw in the beginning of last year, the beginning of this year, in fact, the end of last year, catastrophic bushfires, and my colleagues at Optus, they were basically driving trucks to set up ad hoc communication capabilities because a lot of the towers had gone down, or the towers may not have gone down, but the grid went down and therefore there was no power for the mobile towers to operate. So all of those, actually, some of those problems can be mitigated through having an integrated system that actually identifies problems and in an optimized manner, and in fact in an automated manner too, can in fact reroute communications and provide reliable communications all the time. If we can go to the next one, the next slide. We have just recently, only in the last 2 months, approved a new project that is working with our universities here in Australia, as well as some industry partners and our Defense Science and Technology Group, working with NASA to actually, and NASA's Search and Rescue Office at Goddard in Maryland, to actually work together collaborative to get the next generation of search and rescue technologies to upgrade the systems for maritime safety and so on. But to take a lot of that and actually also put it on land systems as well. So that's a very new project, and it shows the extent of the collaboration that we are very, very keen to broker with Australian universities and industry, and also our colleagues the world over. If we can go to the next slide, please. Some of the other initiatives, we are only 1 year old, 1 year and 3 months old. So, but nonetheless, we are very eager to make some progress and very eager to develop the industry here. The first thing that we've done is we've established a new company of all of our startups. At the moment, there are 66 startups in what we call the Aurora, the SmartSAT Aurora, and that is a space startup cluster that is supported by us financially, but also with capability transfer. Our university helping the startup community. Sometimes it's practically one person at the kitchen table trying to establish a space company. Other times it's a handful of people in a garage and so on. But nonetheless, some of those are really kicking some goals. In fact, only recently, Southern Launch, one of our startup industry partners, launched one of the rockets up to, I think it reached 88 kilometers, not quite in space. And that was the first commercial launch that one startup company here in Australia was able to do. And they do have very, very big dreams. Another startup company that we have is Myriota, a company that came out of the spin-out company from the University of South Australia, with some very unique and very intelligent technology that allows you for $200 to be able to affix a small box, a sensor, your sensor to a box, and then 4 times a day at the moment, that will increase as they put more and more satellites in space. 4 times a day, they're able to take that information and push it to a farmer's iPhone automatically. And that may say where the livestock is, or how high is how empty is the water tank, and all sorts of other applications like that. And now Myriota has had Series B funding, I think $35 million only about a month ago. They are going places as a global company. In fact, they've just established operations in the US and Canada. So they are the small, tiny companies that we really want to help. We've established an international AI for space research network to bring a lot of the capability around machine learning and AI from all over the world. You don't have to be a SmartSAT member, to bring them together so that we can apply the very intelligent tools that they apply here on Earth, apply them on satellites as well. And we are doing a whole bunch of other things that I've shown on this slide, and a few more. If we can go to the next slide.
Thanks, Andy. This roadmap, is that publicly available?
No, because in fact I just came off. I had to leave the steering committee roadmap meeting early to come and present to you. This roadmap is actually being developed as part of the Australia's 2030 Space Industry Growth Roadmap that we initiated. Our chair of the board is chairing that steering group, and it comprises of the Space Agency, GA, BOM, the AGO, the intelligence services, defense, many stakeholders in Australia, who actually, government departments and private, and of course the space industry associations as well, both for space and for spatial, to bring them together so that we can develop a roadmap, and that roadmap would be published. I believe at the moment we're actually working on the timelines just before, possibly around May, June of next year. And that, of course, will become available. And it will have recommendations for government to provide support in growing industry.
Yeah, I think a few industries need a roadmap like that. It looks like it's nice and clear.
And of course, we are very, very keen to partner with others, and we will provide very generous full scholarships as well as top-up scholarships so that we can build the workforce, to build the capability in Australia together with partners overseas. And we have promised 72 PhD completions to the federal government, and around 400 space engineers, scientists, and analytics professionals. So we are very keen to ensure that we build the pipeline, we build the capability, not just only for Australia, but for the world, really.
Wonderful.
And I think the next slide.
These PhDs are live, are they?
They're live. If you go to our website, there's the website link at the bottom, smartsatcrc.com. They are live, and we are very, very keen to ensure that we get some top-class PhD students to start immediately. We have already brokered relationships with our industry partners and others so that the PhD students actually spend time in industry. We don't want them to just become theoreticians. We want them to become the next generation of engineers and scientists for space.
Okay.
And we believe very strongly in collaboration. We are committed to collaboration. We are committed to forming partnerships, and we have already formed quite a few partnerships, but we really want we're kind of open to any collaboration that would make sense, particularly around the roadmap that we have developed. And we have a technology roadmap as well. I think it is on our website, on the specific technologies that we will be working in the next 7 years. And I think that's it.
Okay.
If you go to the next slide, I'm pretty sure that's it.
Thank you so much, Andy. I don't have any questions from the panel, from the audience. If the audience has some, but we do have Andy Bowyer, also from Luxembourg, KLEOS Space, who is on with us. So I'm going to welcome him shortly. If there are any questions, you can feel free to write them in to us. But I think the main thing there for me in terms of the AI and cybersecurity, within that ecosystem, Andy, how much are there pure cybersecurity companies in there? How much attention do you think is being given to that particular sort of domain within a space domain?
Well, that is a very good question, and the very short answer is not enough. There are not enough companies, and not enough attention is being placed, particularly by the startups, the small builders who are, for them, being able to kind of launch and get the satellite up is number one, very, very important. And resiliency of that satellite and security of that satellite, unfortunately, has been up to now a secondary order kind of problem. In fact, probably a tertiary order problem for many of them, or in some cases they haven't even thought of it. And that is a shame and a problem, and that is why we're going to change that attitude. And we have already established a chair in cybersecurity and resiliency for space, and her role is to actually bring that community together and build that capability.
Great. Go, Raman.
I think Raman wanted to ask a question. Or
First of all, thank you so much for such a powerful presentation. I wish very soon in the near future, we'll be doing a similar presentation from a space station. My question is, as a student of electronics and fiber optics, more and more of electronics and silicon is getting into these smarter and smaller satellite technologies, and we have the laws of physics and mathematics which have limitations. Where do you think the miniaturization would end, given the fact that we all have what is called the Moore's law? What is the next big thing going to happen? How small the small satellite would be, just for case of thought? What are the challenges?
That's a big challenge, a big question, and thank you for asking it. I'll have a go to share my individual thoughts about that. Clearly, I think a lot of people have already begun to realize that smaller is not best. I think that 1U satellites were great experiments for university students and high school students even, and they do have some applications, and you can go smaller. But really a lot of the activity, particularly when you are interested in doing some serious operational kind of activities and applications, you really need to have a much larger satellite than 1, 2, or even 3U satellite. Most of the work that we are looking to do would be probably in the class of 50 kg to about 150 to 200 kg. But in terms of Moore's law, yes, of course, miniaturization even now are reaching the limit in terms of going down to atomic levels. And therefore, there will eventually be a limit. Usually what happens, though, is a switch of paradigm. You may be using silicon today. Tomorrow, you might use something else. You might use quantum, for instance. In fact, quantum computing and quantum communications is an area that the SmartSAT CRC will be focusing along with his partners. So yes, the limit is being reached very quickly when it comes to silicon, but then you just shift into another paradigm and another method like quantum computing or biological systems even.
What is your advice to the companies who are invested and still investing in the nanosatellite technologies? Is there a market for nanosatellites?
I'm not sure whether I'm really qualified to know where the market will go in this area. I think from what I understand, yes, nanosatellites at the moment, particularly for experimental purposes, particularly for proof of concept and so on, they are very useful. So there will be a market for launching those satellites in the next 5 or even longer years. But really, most of the serious applications would have to be done with larger satellites rather than just the nano satellites and the 6Us or even 12Us. But nonetheless, there are some applications even now where they are used, and they are used for Earth applications. But actually, in the future, they could also be used for aerospace applications, for the Moon and Mars program, and so on.
Very interesting. Look, I think we've had Andy Bowyer waiting patiently. Also, Andy, thank you so much for your patience. Just check your audio with us too.
Hi.
Wonderful. I was worried that you were using a Mac as well. Professor Koronios.
Good on you, Andy.
Well done.
Just a normal piece.
You two don't happen to know each other, do you?
No, but we've got a good
pleasure now.
Okay. Look, Professor Koronios, thank you so much for your time. You're very welcome to stay on if there's other questions. Andy, and I've got the two Andys here. I'm going to call Andy Bowyer. I'm going to call you Andrew. So, Andy, you're welcome to stay on during Andrew's presentation. But Andrew, you've got a slide deck ready to go. If I can do a screen set with you, or do you want me to bring that deck up that you sent to me?
Yeah, you can bring that. You can bring that PDF deck up if you.
Just 1 second while I bring that up on the screen. So it's obviously not the same as a presentation, so to speak, but full screen, right? That'll do. I think that's pretty good. Oh, beg your pardon. Okay, how's that?
Yeah, absolutely fine. We can work with that. Thank you. So yeah, thanks very much for having me. KLEOS is a space-powered RF reconnaissance company. So we're delivering a new or certainly nascent data set into the Earth observation sphere, really to complement other Earth observation technologies like AIS, imagery, etc. So we're using multiple satellites to geolocate the position of transmitters. So what might have been called in certain spheres as signals intelligence, signal processing, etc. There's a few different ways of. If you keep going a bit further down, it's Control L if you want full screen.
Control L, thank you. That'll do. No, hang on. Wonderful. Good work.
There you go. And so we're providing our data set from our satellites into the ISR domain. So the intelligence service reconnaissance domain, predominantly into defense and security sectors. We are sort of staying one layer above the application aspect. So we work generally with integration partners, with analysts that are providing the intelligence. There's a fantastic community already existing in an analytical sense, from a developing AI methods of analyzing big data sets, particularly in ISR, to deliver solutions, to find out what's really going on there. Those guys are doing the layering. We're generally sitting in fairly early on in the process as a sort of tip and cue type exercise. So very, very simply, overly simply put, where we're finding the presence of, let's say, push-to-talk radio. You compare that against AIS. There's an absence of AIS. That's interesting then from a maritime perspective to bring up, say, an image, whether it's optical or synthetic capture radar, so that you can see what is really happening. So we're part of that picture. We're part of the sort of jigsaw puzzle to work out what's going on around people's borders, around sort of maritime environments that are under threat, whether it's from a defense or a regulatory or security perspective. So we use this term as shining a light on this dark maritime activity. Do you want to jump over to the video?
I will
Chris?
do. Now, just before we do, you're an Australian listed company on the Australian Stock Exchange, correct?
Yeah. So the company is it's a startup. We've been around since 2017. Started in Luxembourg. Most of the team is based here in Luxembourg. We've got a small team in the UK and a small, albeit growing, team in the US. But most of the team here is based in Luxembourg. Luxembourg company. We're actually listed on the Australian Stock Exchange, which is how we kind of raised, if you like, our Series A financing to procure the first batch of satellites, get those launched, and what have you. We've had some challenges to getting things launched, perhaps beyond the normal space challenges. I think there was we were expecting some delay, but COVID certainly threw in an additional layer of delay, which has been a challenge to get over. But we're getting there now, and I can take you through the story.
Great. Let me get this going. 1 second.
Thanks so much.
That should play. One way. I've got to press play actually. Hang on.
So just give it a sort of introduction as we're watching the video.
Do you want me to pause it? Andy, do you want me to pause that? No, I'll play it.
So satellites are flying this is 4, each equipped with radios. We're collecting radio transmissions at each of those points, sending the information to the ground, where the information is then processed using our algorithms. We're finding the artifacts within the noise floor, essentially, to look for radio transmission. So we're using a technique called multilateration to geolocate where those radios are. So that's just a very simple, it's kind of a useful visualization to start us off with regard to what we're doing. So you can just flick back to the slide deck now, Chris. Thank you.
Good work.
Thank you, sir. Do you want to just jump onto the next slide?
Okay. And is there a control button on that? I'm not. Is that down here? Maybe assist me there, mate. Hang on.
Just hit right or left or.
Okay.
Should be your arrow.
I was on my keypad, is it? Okay.
Yeah,
sorry about that.
Use arrows. Okay, so this is basically what we're looking at there. We have these 4 satellites. The video wasn't to scale, evidently. The satellites are about 100 kilometers apart from each other. But what that does is it gives quite a good ground coverage with regard to the ability to collect different radio transmissions. Predominantly what we're focusing on in our scouting mission is push-to-talk radios, as you've seen in the sort of cartoon graphic here. The important thing is there's not a lot happening in space. The satellites themselves are sensors. They're remote sensors. We're not doing much processing. We're not wanting to get rid of any of the signal. We want to be able to really collect as much as we can and downlink as much as we can of essentially the raw transmission, so that our geolocation algorithms and our signal processing engineers can do the best job that they can do on those transmissions. So we get the information back to the ground station, processes through our algorithms, and depending on which iteration we're using in the algorithms, we clean it up various different times in order to find sort of a refined data set, which is essentially the data as points on a map, where we're seeing signals, the time we're seeing them, the approximation of the power of those transmitters. Just it gives them the ability to have another layer in their geospatial intelligence data sets. That is in essence what we're doing. So as we grow as a company, clearly one cluster of 4 satellites isn't a complete solution to all problems. We need to fly a constellation, aiming to fly up to 20 clusters of 4 satellites, so 80 satellites altogether. That gives us pretty good revisit time of most key areas of interest at that stage. Also aiming to broaden things out by adding different payloads. So at the moment we're focused on these push-to-talk radios. We see this as quite an interesting area to look at. They have the ability to identify the location of activity. That activity is usually coordinated using push-to-talk radios, whether it's illegal transshipping or illegal fishing, etc. So if you drop onto the next slide, I think we move on to an application.
So if I down button, here we go, hang on. How's that? Nice.
There, perfect. Well done. So this is just covering off some of the challenges. As I said, our business model approach is really not to develop the applications ourselves. We are working with application developers, so partners, which are generally usually quite large prime contractors. We have some very large entities around the world that we're working with. In Australia, our partner there is a company called SmartSAT, hugely experienced and very well respected defense company in Australia. And they are our channel partner, our ability to bring in different data sets and deliver more of a solution to the customer. So at this point, the company is a data company. We are a remote sensing company. We're flying sensors and delivering data sets. But this is the sort of marketplaces that we're targeting through those routes to market, whether it's regulatory, commercial, or defense. So commercial would be more of your traditional maritime players looking for threats, etc. Regulatory could be illegal fishing aspects, but also could be use of the radio spectrum. We're clearly mapping the use of the radio spectrum. How is it being used? Where is it being used? And the amount of usage there. That's interesting to customers as well. So we are looking for how we can deliver more value out of things like Earth observation, data sets like take for instance synthetic aperture radar imagery. It is SAR imagery is fantastic. It looks through clouds. It can deliver a very, very accurate picture of what's going on. But knowing where to look is often the difficult thing. Where to trigger your satellite to take an image is a difficult thing. So what we're really doing is trying to look at how we can use those assets more effectively, more efficiently through a sort of tipping and queuing type exercise.
So you mentioned, was that tipping and queuing?
Yeah, so tipping and queuing is one of these sort of industry terms, if you like, from a defense sector perspective, where you are queuing other assets. So say, for instance, we found something that we think is interesting, but we aren't able to judge what that is. The best really route there is for a maritime patrol aircraft to go and take an image of it, investigate it, and see what's happening there. It's much more efficient if you can send an MPA to a 1 kilometer block in the ocean, rather than it flying and doing up and down, the coast type normal routine measures. You're reducing the cost of flying the MPA. So tipping and queuing is a useful way of improving the efficiency of assets that already exist, whether they are exquisite space assets or air breathing ISR assets like
And
that.
so your clusters will be, you'll be able to move them around or bring them in. Are they movable?
They are movable, yeah. So
Yeah.
we do carry propulsion. It's limited how much we can move them.
Okay.
So most of the reason why we have propulsion on board the satellites is really to test out different formations of those clusters of 4 so that we can optimize our geolocation accuracy, but also to do some collision avoidance. And then finally, because we're a responsible space actor, is to actively deorbit the satellites at the end of their useful life, and then so they demise through the atmosphere. But we'll do that actively because we're fairly close to the International Space Station. We'll get past the ISS, and then they come back down to Earth with natural drag.
I'll go to the next slide for you.
But that's the reason why we're in propulsion. The way you get cover is by having more satellites. It's sort of the business model of the nano-sat, if you like, where you can't fly around the skies with ultimate freedom. You need a lot of delta V to change orbit, or certainly to change inclination. So we would tend to just fly more satellites. It's much more cost effective to do that.
Great. Okay.
So it's our first mission, the scouting mission. It's somewhat infamously delayed mission. It was due to launch the end of 2019. Satellites been ready for some time. Got pushed back to March 2020, so it's early on this year. So we're launching from India on a PSLV. So we had this sort of normal launch delays. Obviously, at about that period of time when we were just integrating the satellites into the launch vehicle, the world shut down, and it's taken some time to sort of get back in and running. Thankfully, India is getting a grip on how to manage both the economy and also public health, and is back to work and starting on the launch campaign again. So we are due to launch in the first 2 weeks in November now. So that's fantastic news that we've sort of got over this 6 months of essentially pretty dead time. So that's great. Those first satellites are in what's called a 37-degree inclined orbit. So if you look on the left-hand side there, they are within the yellow and red band. They do not see the high north. They don't see the far south. So we see down to about as far as Melbourne in Australia, about as far north as Lisbon in Portugal. I can't remember the Asian equivalent, but it's about that far north is what we see. What's great about that is we see the main areas of interest around the equatorial region many times, more than you would in a sun-synchronous orbit, which is a sort of more traditional LEO orbit that you go into. So it means that we get to see, our challenge areas like the Straits of Hormuz, which is the bottom left there, where you see the formation and the swath of the satellites. So Straits of Hormuz, South China Sea, clearly around the north coast of Australia, where there's a lot of challenges to Torres Strait, etc., which we're working with various different customers on solutions there. Also, a lot of problems where there's significant issues around the west coast of Africa around illegal fishing. There's a very big environmental challenge there. Drug smuggling coming from South America over to the west coast of Africa as well is something we're targeting there, essentially the shipping routes of the bad guys. And we've got...
Andy, sorry, there is a question. Someone has said, how are you picking up sort of the illegal fishing and drug trafficking? I take it that's through their radio communications or...
exactly.
Or observations, actual imagery?
It's so what we're doing is we're not making any judgment. The radio transmissions could be perfectly legitimate. All we are really doing is saying there's an existence of push-to-talk radio activity. There's an absence of AIS. So there's not a legitimate ship in that particular area. So we're not expecting to see activity, but we are seeing radio activity. Radios are used all the time in the maritime environment because they're safe for them to use, because they can only be detected sort of line of sight from a terrestrial perspective, so a few kilometers out, a couple of miles, depending on how high the mast is, maybe a bit further than that. But those transmissions do go to space, so they can't hide from the space antennas, if you like. So we're able to detect that presence of activity, and all we're really doing is saying, there is some activity here which isn't portraying a legitimate signal from an AIS perspective.
Can you identify the radio device through the signal? Does it have a signature?
It has a signal fingerprint, yeah. So we'll be doing a lot of experimentation on the signal processing, the signals intelligence aspect. So early days, we are really just working on locating the presence of a transmission. But this is what I was sort of referring to earlier with regard, we're not throwing any of that signal away.
Yeah.
So that's then interesting as we evolve more of our signals intelligence capability, the ability to find more information in that same signal, we can pull more and more and more data out of that.
Nice.
Starting to attach signal fingerprints to perhaps an AIS transmission. So if AIS is turned off, we know what the ship is or who the ship is, or have at least an idea. And there's some really interesting things you can get into once you start getting down that road. I'm not suggesting we're in that position today. We're certainly not, because we're concentrating on the sort of minimum viable products, if I can put it sort of somewhat crudely, which is geolocation, detecting the signals, making sure that we're getting good, reliable geolocation over and over again. But we have a whole lot of information in that noise floor that we can start to pull out and analyze as we grow as a company, etc.
Is it targeted? Like, is it sucking it up? Like any radio transmission will get detected. It's not selective in terms of its frequency.
Quite a small band. So we are, for instance, with the scouting satellites, relatively refined. So we're picking up all maritime radio channels in the VHF spectrum. So there's 80 odd channels. We're picking up all of those channels. So if they decide to go off their normal channel and much further up the spectrum, or they're using UHF, etc., then no, we can't see that. So the reason for that is partly practicality purposes. Collecting a radio noise floor is a phenomenal amount of data. It's even exceeds that of an imagery satellite or a SAR satellite. So we have to manage that data flow. Otherwise, we won't be able to downlink it practically from a small satellite, even with the most advanced techniques that we're using to date. So there are then some further things that we're doing to increase our collect capability, which is improving our compression on board the satellites. So using lossless compression to try and there's some really clever guys working in that area around the world at the moment. So we're sort of leveraging some of the work they're doing in other areas to apply to our particular technique to collect as much as we can.
Right. And sorry for my ignorance, you mentioned the band around the equator. What's limiting your orbit? Is it regulation or the actual orbit that you're on?
Basically where we get put into from the launch vehicle.
Got it.
So we're put into that 37 degree inclined orbit, and it's very, very well. It's possible, but it's very difficult to change your inclination because you're on a set course from a LEO perspective. So we can change height relatively simply, so we can maintain our orbit. But actually moving out of that particular inclination is you would need a huge amount of delta V to do that, or a huge amount of fuel.
Got it. Okay.
So really, just in terms of the example there, I really wanted to just give a kind of very rough flavor with regard to the amount of sort of data. I think it's partly important from a context perspective. I think people sometimes think with satellites you have a kind of consistent coverage.
Sorry, I just got an echo. Is that your end, Andy?
I'm not sure.
Okay, it's gone now.
It's okay. I think people think from a safe space perspective, you have this persistent coverage. The satellites are always over an area, and it obviously doesn't work like that with LEO satellites. You're flying around the Earth many times a day, and so you're really only seeing a particular area of interest for a certain period of time. Just to give you a bit of a flavour for what that is, if we're looking at the South China Sea, which is of interest to lots of particular customers at the moment, we pick up around 70 hours a month of activity over that with one cluster of satellites.
I was going to say.
So you can see you need to build up more clusters to have a more persistent coverage over a particular area of interest.
Does your 20 hit that mark of near full time? Like, what's your? Because you're at 2 clusters or coming up to 2 clusters now, so you've got quite a way to go.
So 20 is down to around between 10 and 20 minutes revisit times over, depending on where we are in the Earth and the various different factors. But it's a good near real time coverage from a practical perspective. I think particularly when you're in the maritime environment, ships aren't moving very quickly, so you do have that benefit there in terms of things not moving around hugely rapidly, and you've probably got a good period of time there. However, you want to be able to capture all transmissions and see, if somebody happens to be not speaking when you're passing over, and then obviously communicating when you then on the other side of the Earth, then you're not seeing that communication. So we have to be able to create some form of persistent coverage, and also opening up different applications outside of maritime, because we're collecting data over land as well, and there are certainly land applications for the defence and security sector.
Right.
So just drop onto the next slide.
Yeah.
So that's second mission. We have the satellites in build currently for this mission, which is launching in June. SpaceX into a SSO orbit, so sun synchronous orbit. So that means they're going over the poles essentially, and so we see the sort of vertical parts of the Earth with much more efficiency. So really, since we've had the scouting mission, we have got lots of customers engaged and signed up. It's a really interesting one, particularly places like Argentina, Chile, New Zealand, that just simply aren't very well covered by the scouting mission. So we're using the second satellites to fill in some of those gaps around the scouting mission orbit, which is the red line, and obviously the SSO line is the second cluster mission, which we're calling polar vigilance, because it's focusing more on the poles more than anything.
This is launching in India as well, isn't it?
No, this is SpaceX. So launching out of the US.
Out of the US? Got it. Oh, sorry.
Yeah. So this is interesting, complementary, very complementary to the first satellite. And then we'll start to, as we're launching out our constellation, we use different orbits to fill in different parts of our coverage until you have a good coverage of the globe with as most efficient revisit times as you can.
Sorry to ask so many questions. It's a fascinating area, but so your first mission you're launching next month, partner with India, and then you're moving to SpaceX. How does that work in terms of? Is it like catching a flight of, okay, there's a launch next year, they sell that space? Is that how commercial it is now, and you kind of jump on to whatever flight you've got?
Yeah, exactly that. So we are at our level or our size, so our total launch is of less than 50 kilos. So we are what they call a ride share mission. So we bolt onto the side of a main satellite. So the PSLV is launching a radar satellite called 2BR2 for the Indian government, which is quite a big satellite, probably half a ton size satellite, and we're bolting around, and they have a variety of different customers that are bolting on around the outside of that. SpaceX are doing something similar in terms of their rideshare missions. So really, when you're trying to decide where to go, who you're launching with, there's in reality very little choice. And it's certainly not quite a bus service where you can turn up next month and go. You're still needing to plan at least 12 months really ahead of where you can get to make sure you've got a slot booked in. And I think that's going to be probably the most interesting part of the space industry in the next 12 to 24 months is there's a lot more launch capacity coming online. The SpaceX rideshare capability is relatively new still, and they are opening up a large part of the market there. Traditionally, in our size of sector, it was PSLV. It was out of India. That was the launch provider in essence. perhaps Soyuz as well. The ESA Vega launcher is becoming more prevalent. It's probably still only 3 times a year, though. Obviously, Rocket Lab out in New Zealand, which is focused very much on small satellites, but is expensive. So not a choice for everybody. Some folks, but there's a lot more launches coming on board.
Well, Australia should have their own, I think, 2024 potentially. Andy Koronios, if you're still there, if you've got any insights on where we're going in Australia, but I understand both South Australia and potentially Queensland sites could be used. Okay,
yeah, we're tracking these guys very closely. It's important to know what's coming along, particularly as you're sort of rolling your constellation out. We need to be very clear on that. I think the Australian sites are very interesting from a space perspective. The difficult part isn't really the site; it's the launcher, and getting a launcher company engaged and launching from that site. That's you've kind of got the airport, but you need the airlines.
Yes. Well, it's something we covered in our previous. We kind of covered on that a bit in our previous episode 4, and Malcolm Davis made comment that there's a regulatory environment at the moment that needs to be opened up in Australia as well. That's potentially delaying this. Andy, did I hear you there? Welcome to come in.
Oh, yes, I agree with Andy. I think that the capability maturity of the Australian launch industry is not there yet. And I think 2024 is probably going to be too soon, but it'll happen. And the regulatory environment is tough, but there's a good reason for it. But yes, I think that we have aspirations in that area, and therefore eventually we will be able to enhance the launch capability. We've got very determined people, both at the southern launch as well as equatorial launch colleagues that are working very hard. But at this stage, they're not there yet. And that's my view. Anyway. That's my personal view.
Yeah. No, I think I've been really impressed with everybody I've talked to there, and they are, as you say, really great guys. One of the other big holes that needs to be filled is obviously money. I mean, launching is a very expensive business. To build a launch company is extremely expensive. Hundreds and hundreds and hundreds of millions before you're getting to the point of making money, and it's a difficult market. And there's obviously a sort of supply and demand type challenge as well. That it isn't quite a build it and they will come situation. You also need the money to go into the customers of those launch vehicles, people like ourselves. You're looking at the entire chain. So you have satellite builders, you have, if you like, application or data providers, people like ourselves, customers, and then obviously the launch providers themselves. So there's a lot of cash that needs to flow into the infrastructure to make the whole thing work.
I was going to mention, you mentioned the channel partners, so your general IT sector uses channel as its main sort of business model. Is that how you see the space going the same way? You sell through the channel? Because again, they're kind of
certainly our approach.
Yeah.
It is certainly our approach, but it isn't universally people's approach. No, not at all. And I think that's probably reflective of, if you look at imagery, some of the guys have been fantastically successful, like Planet, who have got many satellites in space, taking photos of the Earth and doing great things. They've also developed their own channel capability, but they also work through channel partners as well. So, and that was partly because they were really, they were on the front of the bow wave. They were needing to develop the marketplace as well as develop the technology itself. So they've done a great job at really helping with those sorts of things. I think on the back of that, we're really riding on those coattails, because there is a whole market now built up around analyzing, delivering imagery applications, whether it's for agriculture or maritime or what have you, and we then can sell into that as an additional data layer. And I think that's really helped us open things up. So we're in a fortunate position now where we're not having to create our own applications and marketplace. as well as create the technology and work. So yeah, we're in a good place.
It's good to have that slide up right now, the value proposition. But last week we covered off on robotics and autonomous systems. The week before that we covered off on drone technology too. And just when you're talking about satellites, it's almost like a drone in space. It's just going up to the next few layers. So I imagine, what we're going to see from drones and robotics and those autonomous systems. You mentioned the channel, like how do you meet the customer? I imagine the channel would be a key factor in that, because you're obviously touching base with the IT systems as well.
Yeah, I think in reality, if you talk to an end user, and I think there's something in the space sector we forget sometimes, is nobody cares where the data comes from. They couldn't care less whether you're in space or whether you're flying a drone or UAV, or flying a high altitude plane or a medium altitude plane or whatever it is. They really don't care the source of the data.
And same with connectivity. They don't care how you get connected, but if I'm connected, then that's good.
Nobody cares where you get your TV from. Do you get it from the cable? It doesn't really make any difference. It's important to the satellite providers that they're selling TV through satellites, but the user, the person watching TV, doesn't care. And I think you have to really sort of consider that as a data user as well. It's convenient for us to be in space because we can fly over areas you can't fly over with a drone.
Yeah.
And so we're complementary to the drone capability, but we don't replace it, because obviously drones can cover things much more often because they're in a much smaller area. So it's thinking about the layering and this sort of, I used the analogy of the jigsaw puzzle earlier, that we're all part of that puzzle to deliver an intelligent solution to the customer so they know what's going on. They have whether it's maritime domain awareness or an intelligence piece that is capable of delivering a solution for that. Yeah. And it's many different layers that add up to that.
Yeah, maybe just talk us through this slide here, the value proposition, what the key.
Yeah, I think it's just a wrap up in terms of all the other aspects of really how we're approaching things to be cost effective, to reduce cost time for the analysts, so they are looking at a much smaller area of the ocean rather than the entire ocean, trying to find things and using algorithms to find artifacts within images over the ocean. Multiple customers, whether it's government or industrial customers, really working through the channel partners as I described. Talked you through the roadmap, and obviously we're very keen and we work very closely with lots of other data sets, and it's important for us, touching on your previous speaker there, in terms of partnering people is much better than trying to go out alone. It's certainly very much part of our business culture that we partner with many different other data sets to help build up this overall picture, whether it's the IR guys or the multispectral guys or imagery, etc. All those things come together to deliver a solution to the customer. On our own, none of us deliver a complete solution, and I think it's important that these different technologies, different sensor suites work together to really deliver what the customer wants.
Great. Next slide.
Yeah.
Now it doesn't work. Is this the last slide by chance?
I think it's probably the last slide. Yeah.
Okay. Very good.
Thank you.
Go, Raman.
Thank you, Andy. God bless you. If I have a very typical, techno-commercial question. If I have limited budget of investing $100, looking into the supply chain of satellite companies, where do you think I should invest my money in? Should I invest in the R&D, design, launch vehicle, maintenance, testing of satellites? Where do you think I should invest? Which is the best way to get my return on my investment? Or should I just buy the satellite and sell it?
And no financial advice offered. Raman always goes down the money side.
And visualizing a question, will there be a time in the near future where we'll be selling satellites in the stock markets?
You can buy Geospatial on the ASX.
I would spend your $100 buying stock in Geospatial. It's we're readily available. I haven't checked our share price today, but
100 doesn't mean 100. Put 100x.
Just on that, maybe Raman.
28 Australian cents today. We're a very, very good value. I'd say. To answer your question, I think this comes back to what I was saying earlier. I think the industry is a lot like a kind of house of cards. You need to invest in all the pillars. I'm mixing my metaphors. All your pillars, you need to keep investing in across the board. Have to always invest in R&D, and I don't mean just industrial R&D, but the blue sky, big R, small d, university type stuff. Moving up into the supply chain aspect, you need to have developed satellite providers, particularly in the small space, that are delivering reliable satellites. So they're not university projects that can last maybe 6 months. They're satellites that can last 5 to 10 years, but they're small. Obviously, then investing in the payloads for those, investing in the ground segment, which lots of big players have done, investing in the launch capability, investing in the application and getting those downstream companies, getting them to market. So the AI guys and the machine learning guys and all those guys that are pulling different data sets together and delivering smaller niche applications into market verticals. You need to invest in across it. So I would be splitting it into 10 chunks, putting $10 in each, and I think that you've got a fighting chance of making a successful outcome.
And we won't hold you to that, but we'll see what Raman's money, $100 it turns out in a few years. But
because my association is also investing in certain projects, and we got investors in US and Japan and in India also who are willing to invest on case-by-case basis. So I'll get in touch with you. My second question was a little more technical. Given the fact that satellites are the art of the day, and India is also working on it. So India is also given the thought of reducing the cost of satellite technology coming down. In terms of the electronic warfare payloads coming to the satellite, where do you see the future? You mentioned about the electronic warfare, SIGINT, electronic intelligence. What kind of payload will be there? And what is the market?
It's a very, very defense-centric market, evidently.
Yes.
And I think you have to be cognizant of not commercial space, which we're in, can deliver a supplementary or complementary data set to a governmental asset, but it's not going to replace it. So, there's always going to be a need for the multi-$100 million, well, in the US they would call an exquisite asset that is delivering an incredible capability. Commercial space, and it's been the same in imagery for many years and SAR for many years, where countries have their own assets, but then they're still buying commercial data sets to complement and enhance those, because we fill in the gaps with regards to what's going on. So I think you would need to be quite cognizant with regard overstepping that mark. And at a certain point, a government is going to say, no, this isn't a commercial capability we want to buy. This is a sovereign asset that we need to own. We will own the sovereign asset because this is important that we control the full data set here. So you need to be complementary to that. And so I think there's a point where you would overstep and go into, no, this is not something we'll buy commercially. This is something we have to own as a country.
Can I bring
I think that's a careful line.
Yeah, can I bring out the other Andy, if you're still on the line, Andy, from that research perspective, how are you balancing what Andrew just mentioned, the cross, particularly on the startups, where their startup might be focused on potentially a defense capability rather than a commercial capability? And you might not be there. No? Okay. But anyway, look, on that particular note, we've gone over time, as we normally do on these topics, because they're so interesting. There's no other questions from the audience. Just checking on Professor Koronios, you still there? I'm just going to give a word of thanks, but thank you so much. And Andrew Bowyer, you sound Australian. Are you Australian? In a way, background?
No, I'm sort of Canadian-born British.
Canadian British. Okay.
It turns into a bit of a weird accent.
I was trying to place it. Yeah, but so obviously, and being an Australian listed company, I thought there might have been a connection. But we keep in touch. We get the KLEOS Space ASX media releases, so we'll stay in touch with you. We did reach out to one of your partners here that you just signed a recent deal with. So that's all on Drastic News. And Raman, just a closing comment.
Just to convey my thanks to you and to the panelists, just to remind you that on 8th of October, we have the Indian Air Force Day. On behalf of Chris, my own team, and all over, we wish the Indian Air Force the best of the time. 8th October, remember. The motto is touch the sky with glory, but for Andy and team in space, I say touch the space with glory. Thank you so much.
Very good. That's in 2 days, so enjoy that day, Raman. I'm sure you'll be going. So look, we've been joined by, let me bring up the other presentation 1 second, that should be it. We've been joined by, from KLEOS Space in Luxembourg, Andrew Bowyer, the Chief Executive Officer, and from Adelaide, the SmartSAT Cooperative Research Centre, Professor Andy Koronios, CEO and Managing Director for SmartSAT CRC. Fascinating episode. Thank you so much for your time. Appreciate it's early in the morning there for you, Andy, as well. So these 2 episodes, we'll put a link between our 2 space episodes, but probably the 2 best. So on that note, I'm going to close it off. We don't have any other announcements. Next week, we're mostly likely to be covering off on robotics and potentially computational design in urban environments is an area I wanted to cover. So on that note, I'm going to close it off. These sessions are available on My Security TV, and with the series, we've got 2 episodes to go. So we'll see you here next Tuesday also. Mr. Bowyer, thank you so much for your time. Fascinating, and we'll stay in touch. We'd love to have you on again.
Thanks for having us.
Thank you. Bye-bye.
Thank you.
See you, Raman. See you next week.